All right, guys, we are in for the last installment of your Do Now of the Week. Get excited. So I know that I put these copies in a weird order, so I apologize, but 477. So 1, according to the data presented in Table 1, so this is IOD, what is percent concentration at 50 kilometers? So Table 1, the percent concentration, so 50 kilometers, and the percent concentration of O2. So you just trace your passage, 20.94, and the answer is C. That's probably the easiest question you'll have on this passage. Although, as I am going through this passage for the first time, I don't know yet. Okay, number 2, the percent concentrations of which of the following gases are constant below an elevation of 90 kilometers. So that means that it's the concentrations of these gases. So which ones are constant? So that's this one does not change, this one does not change, this one does not change, this one does not change. H2O is the only one that changes. So that's N2, O2, He, and H2. N2, O2, He, and H2. Let's double check. N2, O2, He, H2. Nope, H2O doesn't change. H2O doesn't change, so we can X off F and G. N2, O2, and H2. N2, O2, He, and H2. That's all 4 of them. Hooray, your answer is J. That's an IOD question yet again. Okay, number 3. Which of the following graphs best represents the relationship between O2 concentration and elevation? So let's see, O2 is constant, so we're going to have a graph that looks like this at 20.94, and then it shoots up, and then it goes straight back down to 0. So the graph's going to look something like that. That kind of looks like a cattail. I would draw a picture if we had more time. So the elevation and the concentration. So, we put concentration on the y-axis. So this is our 20.4 section. That seems pretty high for 20.4. And then we have to have a shoot up section. And we have a shoot up section here, so 20.4. But then goes back down to 0 for number 3. So we need a big drop after. This one has a plateau. So it would be between D and A. You can cross off these because they don't have the increase. They don't have that spike that we need. But this one does not have the drop. So our answer is A. That's IOD as well. Okay, that's translating something from a table to a graph. Number 4, according to table 1, the concentrations of H2O at 10 kilometers. So this one's pretty easy too. So at 10 kilometers, and H2O. So it's going to be somewhere between 2 and 1. This is an interpolation question because we only have 0 and 15. 10's not on the table. So somewhere between 2 and 1. So it's not going to be 1, it's not going to be 2, it's definitely not going to be 10. So your answer to 4 is G. It's the only answer between our 2 knowns. And that again is IOD, 404 if you're curious. All right, a group of researchers sent up a weather balloon from their lab. The balloon sent back a temperature reading of -20. Given the information, which of the following elevations could possibly be the elevation of the balloon? So this is actually EMI. So -20. Where do we have that? So it could be between, let's see. It could be between 15 and 50. That seems where it could be between 15 and 50, because -20 would fit in right here. 25 is. So it's like at 0 elevation, you have a normal temperature, 25. Then at 15, it gets colder, 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 and then really, really hot if you go here. So the Earth's atmosphere heats up after this point. Alrighty, so between 15 and 50. So now we're gonna look here. So set 15 to 50. No. Then let's see if there's anything else. Oh, also, it's gonna be between negative 90 and 900, so that would be 90 to 200, because it's going to heat back up, so it's going to have to pass through negative 20 to get to this point. So there are two places where it will pass through. So that's a tricky question. 15 and 50, and then, what was that? 90 to 200. So, let's see. Any other time? Oh, it's also going to pass through right here, because 20, it's going to have to drop. So 25 to negative 45, it'll hit negative 20. Then negative 45 to negative 5, it'll hit negative 20. Then negative 90 to 200, it'll hit negative 20. Third place. So that one is actually between 0 and 15. So we need distances that cover all of these bases. So 7 hits the 0 to 15 mark. 15 to 50, that's right there. 90 to 200, 116. 72 is below. So it looks like our best answer there. Oh, negative 5 to negative 92, and 50 to 90. So it's actually going to hit 4 places. Just keep discovering them. So the best answer is actually going to be D. That's our most inclusive point, because it shows you all 4 of the ways. So there are 4 times where it'll pass through that number. This is actually probably the most difficult question, so I'm going to give this 3 stars. That's one of the most difficult questions I've seen you get. All right, number 6. Suppose a rocket malfunctions on its way to outer space. The last reading the rocket sent to Earth before malfunction were an atmospheric O2 concentration of 33.75. So O2 equals 33.75. H2O is 0. And temperature is 285. Okay, so 285. Temperature of 285 is going to be somewhere between here. And the O2 concentration was 33. The water concentration was 0, so it's looking like we're somewhere between 90 and 200. So somewhere between 90 and 200. So no, no, no. And our answer is H. That one was much easier than number 5. I have D. And number 7. Okay, according to the information in figure 1, first time we've had to look at figure 1. Between 50 and 85 kilometers, this is a trend question, as elevation increases. So figure 1, between 50 and 80 kilometers. So we're going to look there. As elevation increases. So as we go this way up the graph, what does the temperature do? So increasing the elevation, because that's the kilometers on this side, the temperature is doing what? It goes from 0 to negative 90. That's a decrease, so the temperature is decreasing. And that's a wrap.